Okay, in this presentation we are going to look at clustering analysis with Julia. This is a k-means clustering algorithm that we're going to use in this particular presentation. So the setup is, first off, we're going to use the package manager pkg to add the clustering package to our working environment. So just pkg.add clustering. Okay, just notice that it's capital C clustering. Also just that it's capital P package pkg. Okay, so once we have that done, we won't do that in Jupyter notebooks, we sort of do it in the background, but once we have it done, we can then sort of run this cell here using clustering. Now it just takes a moment, partly because when you're recording it just takes a little bit of extra time just to do things when you're recording. So anyway, it should be ready now. So the first thing we're going to do is set up a data set to work with. So we're going to create a random data set called X that comprises 2,500 observations. I just picked that number 2,500 myself. Each point is a 6-dimension vector, which is to say 6 variables. So we have 2,500 observations with 6 variables. So let's run that. Okay. Just give it a second there. It should pop up now in a second. There we go. So yeah, 6 by 2,500, 6-dimension vector. There we go. So in this case, each column corresponds to an observation. Okay, the type of X, just to sort of check that we have everything working in order. Not that it's really necessary for this particular matter, it's just to note that it's matrix. So what we're going to do is perform k-means over X and try to group the data set into 25 clusters. Okay, I just picked that number 25 myself just to sort of feels right. Not that it's important. We're going to set the maximum number of iterations to 200. Now you sort of see what I mean by this, that if it doesn't settle on a solution after 200 iterations, we just pick the 200th iteration. We're going to set the output display to iter so we can see the information at each iteration. Okay, so we're ready to go. This is the key line here. R equals the results equals k-means, X the data set, 25 the number of clusters, max iter the maximum number of iterations, and display equals iter. Okay, so let's run that. Give it a second. And a bit of work there. There we go. So it's going to come out now. So what happens is that each observation is assigned to a particular cluster, and what happens at each iteration is that it gets reassigned based on whether or not it'd be better off in another cluster. So there's quite a high degree of volatility that in nearly each case the clusters are changing membership. So we have 25 clusters and the membership is changing constantly. But now they're starting to settle down. 21, 23, 24. Well, go back up a bit. Oh, it's going back up again. But so that's not so serious, but you see that ultimately it's starting to go down and down. So when we hit 22 iterations, some of them have really settled now. So at iteration 23, there's only 7 clusters being moved around in terms of membership. 4, 3, and now 0 and 0. So essentially the membership of each cluster has stopped changing. Okay, so that's the sort of off-ramp of the process. So things are not moving now, so we'll just cut it out there. So k-means converged with 27 observations. So I'll leave that number for another time. It's interesting, but it's a bit too technically detailed for what we're about to discuss. That gives us some information there, quite a lot of information. It's the results there, but it's a bit too dense. It's a bit too hard to read there. So we'll move on from that. I just had to pause for a second because the browser slipped on me. So I'm just going to backtrack a second. The number of resultant clusters should be 25, so we can check that by using n clusters, where the input R is the results of the clustering algorithm, the k-means clustering algorithm that we have used for our 2,500 observations. So just run that again, and we confirm that we have 25 clusters. What we also would be interested in is seeing how each observation was assigned to a what cluster each observation was assigned to. So there we would go assignments of R. So let's run that again. And this tells us that we have 2,500 assignments. So the first observation was assigned to cluster 11. The second observation was assigned to cluster 19. The third, fourth, and fifth observations were also assigned to cluster 11. That's just pure randomness, pure fluke that 4 of the first 5 happen to be in the 11th cluster, but pay no heed to it. Down the line you see that it's much more random. So that gives us information about the assignments of each of the 2,500 observations. Let's just check what the 333rd observation, what cluster it was assigned to. It was assigned to cluster 18. Something I do every so often is I just check the type of a vector. Okay. Finally, two things we would be further interested in. We want to obtain the count of observations in each cluster. So we have 25 observations, 25 clusters with 2,500 observations. Now we would expect about 100 observations per cluster, but that may or may not be the case. So counts of R just gives us the count of each cluster in terms of the number of observations assigned to that cluster. So we have 97 in cluster 1, 103 in cluster 2, and so on. We noticed previously that there was of the first 5 observations, 4 were assigned to cluster 11, and it turns out there are 111 observations in that cluster altogether. Finally, what we would be interested in is the mean vector, which is to say the mean of each cluster, the center of each cluster, the centroid. Okay, so to find that we go .r.centers, that is results, and this just extracts the centers from that analysis. Okay, so this will return 25 observations, 25 centers, which is denominated or expressed in terms of the 6 variables that is used to express it. Okay, so this is the first center, the first column there. Well, okay, you can see the first column there. The second center is the second column, and so on. Okay. And yeah, that just returns that again. Alright, okay, great. We'll leave it there. Thank you. Bye-bye.